Welcome everyone and well done on successfully completing week 1 of the higher course. This week we will continue with Metabolic Pathways, which is the first outcome, first key area in Unit 1 of Enzymes and Metabolic Pathways. There are 3 learning intentions this week, one being to describe the free proteins found in a cell membrane. Number 2, to describe how forward and backward reactions are controlled. And number 3, to explain the role of induced fit and activation energy in enzyme activity. We will now look at the first learning intention, which is the structure of the membrane. So from S1 through to National 5 Biology, you will remember us describing the cell membrane function as controlling what enters and exits the cell. In National 5, we expanded on this, explaining that the 2 structures found in the same membrane are called the phospholipid bilayer and proteins, as shown in the diagram below. This diagram that's now on the screen is the one that, if you did complete National 5 Biology, you will be more familiar to, and very often you would be asked to label the proteins in the cell membrane and the phospholipid bilayer. However, with higher, everything expands and we go into more depth. What we need to actually explain to you now is that there is 3 types of different membrane proteins that are found in the cell membrane. These are called pumps, pores, and enzymes. You may remember from National 5 Biology, active transport, that we would talk about in transport across membrane. And very often we would explain active transport as being where molecules or ions are pumped from an area of low concentration to an area of high concentration. And we would always say that this required ATP, which is known as energy. So the role of pumps are to pump ions in and out of a cell by the process of active transport. The fact that it's called active transport leads you to know that it actually needs energy because it's actively being done. If you look at the diagram on this slide, on the first part of the cell membrane, you will notice that there's only one little hydrogen molecule on there. And on the opposite side, you will notice that there's lots more hydrogen molecules. This again emphasises that it's moving from an area of low concentration to high concentration. The second type of membrane protein found is called a pore. And what a pore does is it allows molecules to move in and out of a cell by diffusion. Again, this is a term that you may recognise from National 5 Biology. However, if you have not completed National Biology, that's okay. The opposite happens here in a sense that the molecules move from an area of high concentration to low concentration and they just drop through the pores, therefore no energy is required. You do not need ATP. We call this a passive process. It's probably more clear on this next slide. As you can see, at the top of the diagram, there is lots of molecules, if you were to count them up, compared to at the bottom of the pore, there's less. So this again backs up the idea that the molecules are moving from an area of high concentration to low concentration through the protein pore. And again, it's just detailing the phospholipid bilayer in the diagram. The very last one, which most people will be familiar with, is enzyme. We all know that enzymes are biological catalysts found in the cell membrane that speed up cellular reactions, and enzymes are what controls each step in a metabolic pathway. You'll remember this from last week's lesson. An example of one of these enzymes working is when ADP plus PI is synthesized by the enzyme ATP synthase in order to make ATP. This is probably one of the most common ones that you need to make your cell more familiar with, and we do explain it more when we get into the second topic called cellular respiration. But for the moment, all you need to know that enzymes are a type of protein that are found in cell membrane. Okay, the second learning intention for today is to be able to describe how forward and backward reactions are controlled in a metabolic pathway. Okay, so what we already know that one step in a metabolic pathway can be a reversible step, and it is very often shown by the two arrows going in opposite direction. It's not full arrows, remember, it's a little half arrow shape at the side of it, like in the diagram. Okay, so in this scenario, A would be your substrate molecule, and enzyme 1 would break A down into product B. However, in the reversible reaction, it then becomes B, that is the substrate, that is then converted into A, the product, by enzyme 2. And this reversibility is dependent on the concentration of the substrates and the products involved in the enzyme reaction. These reactions are referred to as forward and backward reactions. Okay, again, so we just look at the diagram. The forward reaction in this diagram would be from A to B, whereas the backward reaction in this diagram would be from B to A. Now, the question is, when is the forward reaction instigated, or when is it the backward reaction? What are the scenarios that would cause A to be converted into B or B to be converted into A? So the scenario when the forward reaction would occur, which is from A to B, is when you have lots or a high concentration of A. So we have lots of the substrate concentration A, which would then in turn make enzyme 1 break down A into B. The other case where a forward reaction would occur is if you didn't have lots of B, therefore the metabolic pathway needs B, we would then, so it was, if B was at a low concentration, the forward reaction would occur to let the metabolic reaction continue because we need B. So the way to promote the backward reaction is just the opposite of the forward reaction. The way that the backward reaction would be working, if you had a high concentration of B, it would then convert it into A, or you had a low concentration of A, it would then cause the backward reaction to happen. So very often you will be asked questions of what must the concentration of A and B be in order to promote a forward reaction or a backward reaction. Okay, guys, this is quite tricky, especially when you're not in a classroom and you're not doing it on a board and you're not highlighting and explaining the reaction, showing the concentrations of the substrates and the products. So I just want to reiterate that again. The forward reaction from A to B will occur when A is at a high concentration or B is at a low concentration, and the backward reaction from B to A will occur when B is at a high concentration or A is at a low concentration. We will now look at the third learning intention for this week, which is to explain the role of induced fit and activation energy in enzyme activity. Okay, so when we look at a recap from last week, what is a metabolic pathway? We know that metabolic pathways are controlled by the presence or absence of particular enzymes that are regulated by the rates of reactions in their pathway. If you look at the example on the diagram, A is the substrate molecule, which is acted on by enzyme 1 to then create B, the product molecule. If we go into this in further detail then, we would say that substrate molecules are acted on by specific enzymes and have a high affinity for their active site. Affinity is just another word that explains the degree of attraction between two different molecules. Okay, so for example, the enzyme active site has a high affinity for the substrate because the substrate is attracted to the active site to bind in order for the reaction to occur. If you then look at the second diagram, it explains that the products in the reaction have a lower affinity, allowing them to leave the active site. Okay, and it clearly shows that the products are moving away from the active site because they are not attracted to the active site. We then look at the next factor that can have an effect on enzyme activity. If the active site and the substrate do not bind tightly together, this will in turn reduce the rate of reaction and how well the enzyme actually works. The way that enzymes solve this problem is through this process called Induced Fit. Induced Fit is when the active site changes shape to better fit the substrate after the substrate has bound. Now, the key word in this definition is the word after. The active site will not change shape before the substrate binds. It's only after it binds it will then change shape so that it becomes more tightly fitted around the substrate, which will allow the enzyme to do its highest reaction. This is often referred to quite similarly as a memory foam mattress. I'm not sure if any of you have a memory foam mattress at home. But basically a memory foam mattress is flat. However, when you lie on your mattress, the mattress then molds to your body shape as opposed to it remaining flat. Okay, so the idea is that your body molds into the specific shape and you get a better sleep because the whole mattress is surrounding your full body, as opposed to a normal mattress where it would just remain flat and your body is not molding into that shape. This can be seen in the diagram below. If you look at the first picture on the diagram, look at the active site. As you can see, the lines are not very sharp, and if that substrate were to fit into that, it would not tightly fit around, particularly the half moon circle shape. If you then look onto the next picture in the diagram, you can see that the enzyme active site has changed shape slightly. What it means is that the substrate is now tightly binded in. If you then look at the next picture, it shows that the enzyme has now created the two products. And very lastly, the last picture shows the products leaving the active site as they have a low affinity for it. And if you can see, the active site shape refers back to the first picture, so that it's now the same shape. So it's losing that induced fit model. Another factor that can affect enzyme activity is activation energy. Now, all you really need to know is what is activation energy, and it is the energy required to start a chemical reaction. Okay, the less energy required to do this will in turn mean you have faster reactions. So the introduction of enzyme allows us to speed up chemical reactions as they lower this activation energy required to form products from the reactions. So this is how that enzymes have the definition or the function of speeding up chemical reactions. They actually do this by lowering the activation energy required. If you look at the following diagram, along the bottom it's got the progress of the reaction and up the side the energy needed. The reactant would be your substrate, that binding with your enzyme. If you look at the bold line, it shows that the activation energy needed when an enzyme is not involved is a lot higher when you look at the dotted line, which shows that the activation energy needed when you're using an enzyme is much smaller. Okay guys, so that is us now completed the free learning intentions for this week. Just to reiterate, you should be able to describe the free proteins found in a cell membrane, to describe how forward and backward reactions are controlled through substrate and product concentration, and to be able to explain the role of induced fit and activation energy in enzyme activity. Now, I am aware this is completely new to yourself and a new different way of learning. You have access to this PowerPoint throughout the whole year of this course, so you can go back to it. My suggestion would be to listen to the PowerPoint once through, and then maybe listen to it again, and then take your own notes in like a notepad or a class jotter. You must do this before you even attempt the assignment questions. And then you might want to recap the PowerPoint again before you attempt the quiz that will be published on Thursday morning. You can also use the summary notes. Pages 2 and 5 are the 2 pages that will help with the concepts that we've discussed today. As always, BBC Bite Size is an amazing tool. And Study Stack, again, you can always use just as a little recap and a revision tool. Pop in and out of it at any time, just to check and consolidate your own learning and understanding of these subjects. Study Stack kinda will be a replacement for doing whiteboards. You know, normally we would do whiteboards at the start and the end of the lesson to consolidate. You can do this through Study Stack. Okay, guys, I hope all of that is easy to understand for yourself. Again, any questions at all, just drop me a little message on Teams or email. Okay, bye. Enjoy your day.